Okay, trying to get some videos made here for you guys, get you caught back up. I feel like my voice is back. So today we started working on lesson 3.6. Whoops, wrong thing. Proving theorems about lines. And this is a two-part lesson because some of the problems later on involving distance between parallel lines gets a little confusing. Also today we went through some proofs. I will try to pull up those proofs also and do a separate proofs video. There will be a proof though in this video to help you out. So the other day we did some constructions. If you want to go back, obviously in class when I clicked these links it would take me to the construction, but you can type those in at a later date into your URL and go ahead and make these first two constructions that we did in class. We did the warm-up exercise in class. We've gone through these. I'm going to give you a minute to look. Try and do these. You can pause your video. Number one is distance formula. The answer is 5. Number 2, whoops, I moved the wrong thing, but you get the point there. The answer is 90. As I said, we did those in class. We did this paper folding activity in class. Basically wanted you to see that when you fold the lines, you make perpendicular lines that intersect and make 90-degree angles. So this is a lot of theorems. Theorem 3.8. You may want to pause this, copy these down. If two lines intersect to form a linear pair of congruent angles, then the lines must be perpendicular because if they're a linear pair, they're 180 degrees. So for them to be equal to each other, they would have to each be half of 180, which is 90. 90 is right angle. Theorem 3.9, if two perpendicular lines intersect, they form 4 right angles. And they ask you to go ahead and draw some conclusions. What can you conclude about angle 1 and angle 2? Well, you can conclude that they are both right angles. You can also conclude that they are congruent. That's the right angle congruence theorem from, I believe, chapter 2. Theorem 3.10, I feel like this word two non-adjacent sides, not just two sides, because the non-adjacent sides, so if we look here like ray B, D, I put that point in, would be the adjacent side. So obviously these are going to add up to 90 because they are on the interior of the 90-degree angle. Okay, they asked you to go ahead and prove theorem 3.10. They told you that ray, be careful here, this line says ray ED is perpendicular to ray EF. And we're proving that 7 and 8 are complementary. So that first part is the given. Now, this is me. I told you I'm starting to do more and more of my own proofs because I don't like the book. The book says that DEF is from theorem 3.9, perpendicular lines intersect to form 4 right angles. I just don't think that's really a good use. First of all, it says perpendicular lines. These are rays. And there's not 4 right angles here. There's just 1. So I really think that a better would be definition of perpendicular. Perpendicular line rays are going to form that 90-degree angle. And the fact that it's a 90-degree angle is equal to 90 degrees, that is the definition of a right angle. If I add those two interior angles that make up DEF, the measure of angle 7 plus the measure of angle 8 equals DEF, that's the angle addition postulate. Okay? Measure of angle 7 plus measure of angle 8 equals 90 degrees. Well, if it's equal to measure of DEF, it's equal to 90 degrees via substitution. And 7 and 8 are complementary. That's the definition of complementary, that you add up to get to 90 degrees. Reset that, so it's ready for the next class. Guided practice, what can you conclude? What can you conclude about 3 and 4? You can conclude that they're going to add up to 90 degrees, really, so you're concluding that they are complementary because they are the interior angles of a 90-degree angle. There's 2 more theorems. Perpendicular transversal theorem. If a transversal is perpendicular to one of 2 parallel lines, it's perpendicular to the other. And in a plane, if 2 lines are perpendicular to the same line, they're parallel to each other. So you have some lines here. Determine, if any, which lines must be parallel. So P and Q are both perpendicular to S, so they're parallel to each other. And S and T are both perpendicular to Q, so they're parallel to each other. Use the diagram at the right. Is B parallel to A? Well, yes, because they're both perpendicular to D, so if they're perpendicular to the same line, they're parallel to each other. And is B perpendicular to C? Well, it depends. If they tell me that C and D are parallel, then if it's perpendicular to D, it's perpendicular to C. But I don't see anything here that tells me that they're parallel. Maybe I'm missing the obvious. Let's see what they have. They're saying, yes, by the perpendicular to a transversal theorem, B and C is parallel to D by the lines perpendicular. Oh, so I see. They are parallel to each other. That's over there. I missed that step. So C and D are parallel because they are both perpendicular to A. I was just looking at this part of the drawing. So since they're parallel and B is perpendicular to D, B has to be perpendicular to C. Okay? And another proof that we want to go through here. We're proving theorem 3.8. Angle 1 and 2 are a linear pair. That's what we're given. Angle 1 and 2 are also congruent to each other. They want us to prove that G is perpendicular to H. So 1 and 2 are supplementary. Okay? That's the linear pair postulate because they told us that they're a linear pair. So the linear pair postulate says that they're supplementary. So for number 1, the definition of supplementary would be the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And sorry, you're getting a little bit of the announcement overhead, but we will deal with that. We'll wait for them to finish talking.
Send those students to the auditorium.
Okay, so that's the definition of supplementary. They were also given that 1 is congruent to 2. That means the measure of angle 1 is equal to the measure of angle 2. That's the definition of congruence. Then what I did was, instead of saying measure of angle 1 plus measure of angle 2 equals 180, we substituted in for measure of angle 2, the measure of angle 1 again, and combined like terms, and then went ahead and divided. So that over here, if the measure of angle 1 is equal to 90 degrees, angle 1 is a right angle. That's the definition of a right angle. And G is therefore perpendicular to H, because that is the definition of perpendicular lines. If the lines intersect to form a right angle, the lines are perpendicular. Okay, let me reset this one. And we have another proof that I want to do with you guys just to give you a little bit more practice on proofs. So if you want, you can freeze this, try and get the answers. But you're given that H is parallel to K and J is perpendicular. H is parallel to K and J is perpendicular to H. We want to prove that J is perpendicular to K. Yes, there's a theorem that says that, proving that theorem. So let's see what we got. The first step is angle 1, angle 2 is congruent to angle 2. Now, once again, this is one pulled from the book, so I'm going to interject what I would want to have here. Meaning, I would want to have a step here that says angle 1 and angle 2 are corresponding. And that would be the definition of corresponding. Because otherwise, I'm using the corresponding angles postulate saying that they're congruent because they're corresponding, but I haven't said that they actually are corresponding. So the measure of angle 1 is equal to the measure of angle 2. That is the definition of congruent angles. Angle 1 is a right angle. Perpendicular lines intersect to form 4 right angles. So the measure of angle 1 is 90 degrees. If the measure of angle 1 is 90 degrees, then the measure of angle 2 is also 90 degrees by substitution, because I've already said that they're equal. Angle 2 is a right angle. Well, that's the definition of a right angle. And then if this is a right angle, then by definition of perpendicular lines, that's a right angle. So the only thing that I really feel like this proof here was missing is stating, which is kind of the obvious, but you still need to state that angle 1 and angle 2 are corresponding angles. Okay. At this point now, I'm going to stop this. We go on to lesson to finding distance between two parallel lines and between a point and a line. And I really feel like our textbook is a little bit lacking, so on the next video, we are going to go ahead and use the Glencoe book to review that concept, those concepts.